Okay, this is Unit 6, Lesson 9. Am I right? Unit 6, Lesson 9. Yep. Okay, Unit 6, Lesson 9. What are cross products? Can somebody explain what are cross products? Amani, go ahead. Can you give me a little more details about that? Abu, can you help him out and can you put that away? Thank you.
Cross products are a way to are
How do you find the cross product? How about that? Maybe that's better. Jonathan.
Multiply the numerator and the denominator of the numbers.
Nice. Okay, that's much closer. Take a look at the answer. This is the book's answer. What are cross products? For two ratios, the cross products are found by multiplying the denominator of each ratio by the numerator of each ratio. Okay? Basically what Jonathan just said. Okay, solve each proportion. Okay, there's a couple methods. I'm not going to post the mental method, but if you can explain your method, go ahead and share that with us. Christian, go ahead.
The first one I did because I saw that, I found out what I found out what 12 divided by 3 was, and that's 4. So I multiplied 2 times 4, that equaled 8.
Okay, so you found the factor that takes you from 3 to 12. So 3 times 4 gave you 12, so 2 times 4 gives you 8. The answer was x equals 8. Cross product method, that's the more, that's a pretty standard method. You're going to use that more frequently. For the easier problems, mental method's okay. Make sure you explain your steps. We see that when we simplify this, 24 equals 3x. How do we isolate x over here? Go ahead. So here I have x and 3. To get rid of 3 times x, we're going to divide both sides by 3. 24 divided by 3 gives me 8. The 3's cancel out. I get 8 equals x, or x is 8. Same thing as Christian. Okay, who's got number 3 for me? Who can explain that? Can I get a volunteer? Somebody I haven't heard from yet. Rudy, can you walk me through this one?
Well, I multiplied 27. Well, no, I divided 9 into 27, not 3.
Okay, so you see that 9 times 3 gives you 27. Okay, continue.
And then I multiplied 5 times 3, got 15.
Okay, so you got y equals what?
Y equals 15.
Correct, so 5 times 3 gave you 15. Or you could have used cross product. 5 times 27, 9 times y. That gives you 9y equals 135. Isolate y in this case. We're going to divide both sides by 9. And we get the same result that Rudy had using the mental method, y equals 15. Okay. Now, are you always going to be able to use mental method? Not always. When you can, yeah, definitely use the mental method. Okay, so for number 4, who's got number 4? Somebody I haven't heard from yet. Tayana, can you tell me how to do number 4?
Multiply with the LCD is 5.
Okay, so the factor in common with 5 and 25 is 5. Okay, so what'd you get for m in the bottom?
5.
So 5 times 5 gives you 25, right? Or 25 divided by 5 gives me 5, right? So if I'm going this direction, what's 5 divided by 5? 1. So do you see how it's 1? If you need to double check, we can do cross product method. 5 times 5, m times 25. That gives us 25 equals 25m. Divide both sides by 25, we get 1 equals m. Okay? So you got the correct factor. I think you're thinking on how to solve for m. Yep. All right, go ahead. Number 5. Mm-hmm.
Since I couldn't exactly find a whole number that multiplied by 18 that equals 21, I multiplied 6 and 21 together to get 126.
Okay? So you took the cross product. 6 times 21, 126, and then t times 18. So that gives us 18t equals 126. Then how do we isolate our variable?
You divide by 18.
Divide both sides by 18. And what did you get for t?
7.
T equals 7. Okay? All right. So it wasn't obvious what my factor was. So cross product method was the way to go here. Do you have a question, Timothy? You had a different way? Okay, share with us your way.
So if that divided 18 by 6 equals 3.
Uh-huh. You found 18 divided. Okay, so you're thinking, all right, if I took the reciprocal, what's the multiple between 18 and 6? You got, so this would simplify to 1/3, right? And how can I rewrite this so it's 1/3? 7 over 21 is the same as 1/3. Okay, that's another method. That'll work. Okay, moving right along. All right, so I don't know if you can tell in this picture, but I believe this is a toy cow, and in the distance, that's actually a real windmill. But that's perspective, so it's like really, really close to the camera, and then off in the distance is the windmill. All right, but let me go ahead and read this since I'm putting this together for the class YouTube channel. What you'll learn to use proportions, What you'll learn to use proportions to solve problems involving scale. New vocabulary, scale drawing, scale. Why learn this? When you know how scales work, you can see them in everything from maps to giant sculptures. A scale drawing is an enlarged or reduced drawing of an object that is similar to the actual object. A scale is a ratio that compares a length in a drawing or model to the corresponding length in the actual object. If a 15-foot boat is 1 inch long on a drawing, you can write the scale of the drawing in these 3 ways. So this should look familiar to you, right? What does this remind you of? Remember, ratios can be written 3 different ways? Okay, except for the way that's missing is what? The word 2, okay? All right, any questions about that? Okay, let's go to our first example. So this relates to what we're doing for our portfolio projects that's due later this week. Now for this portfolio project, you're going to be drawing a scale map of your room as it is. Furniture, windows, all that's going to be included. Then you're going to rearrange your room, and you're going to draw a scale map of your redesigned room. There's a couple essays that go along with that worksheet. Make sure you complete those essays if you want the full points. It's pretty self-explanatory, but this lesson basically relates to that portfolio. So I wanted to just mention that this problem ties in very nicely with our portfolio project this unit. Okay, example, using a scale drawing. The length of the side of a house is 3 centimeters on a scale drawing. What is the actual length of the house, of the side of the house? So if you notice, you guys see this information right here? Every centimeter of the drawing represents 2.5 or 2 5/10 meter in real life. So the first thing we need to think about is, what is the scale? Okay? Now, what am I trying to figure out? Am I trying to figure out, what are they giving me? What do they want me to find? Fatima, what are they trying to get me to find?
Trying to find like the actual length of the side of
The real length of the house, not the length of the drawing, the house in the drawing. So they're telling us that if they measured the length of the house, how long is the length of the house? If they measure the length of the house in the drawing, how long is it in the drawing? Abu? How long is it in the drawing? They said, hey, look, here's the house. Here's a drawing of a house. How long is the length of the house in the drawing, not the actual length?
3 centimeters.
Right. So we know it's 3 centimeters, right? They give us this relationship right here. And we're going to use this relationship to write a fraction. Okay, so they're saying, hey, this in this drawing equals this much in real life. Okay, well, if that's true, then we can use that to write our relationship. So do you guys see what I did? It's very similar to what we did to convert units. You guys remember that? Okay. Now, I took the reciprocal of this. Why did I take the reciprocal? Do you guys remember from what we did before when we converted units? Who can explain to the class why I took the reciprocal? Terrell.
Change or flip, keep, change or flip.
No, I'm not dividing. I'm not keep changing. That's not why I have the reciprocal here. There's a reason why.
Because of the centimeter thing?
Yes, because the centimeter. What about the centimeter thing?
You want them to cancel out?
I want them to cancel. Beautiful. So if these cancel and I multiply straight across, then I'm just ending up with my meters. Do you guys see how that works? Okay. So I use this relationship, but again, you have to be careful about how you're going to use the relationship. Because just like 1 centimeter equals 2.5 meters, 2.5 meters equals a centimeter, so I could rewrite that ratio. Okay? Does that make sense? Okay, now what I want you guys to do, same house, except for they want you to figure out what is the actual height of the house. We're using the same information, except for now we're given the height of the house. So who can walk me through this? Somebody I haven't heard from yet would be nice. Alexandra, got any ideas? You're going to multiply 2.5 times 4. Yes. I broke it down using fractions again over here. So take a look. We have our relationship from above. So this is what we start out with, 4 centimeters. I put it over the fraction 1. And I'm going to use this ratio again to convert, because I want meters, right? So then when I multiply that, what did you get when you multiplied that out? Who got the value? Logan? 10 meters over 1, or 10 meters is the actual height of the chimney. Okay, any questions about that? Okay, moving right along. Okay, so I had to kind of play with this drawing a little bit. So I have a ruler, and this is in the book, but now you're going to see how we're going to use this ruler in the book, from the book. So, excuse me. You can use the GCF to find the scale of a drawing or model. So here it is, application geography. Find the actual distance from Charlotte to Winston-Salem. So here's what we're going to do. You see this ruler? Do you see the scale over here? It says each centimeter is worth how many kilometers? Okay, so what I did is I took this ruler, and you see that this is exactly 1 centimeter, right? I need to measure it from Charlotte to Winston-Salem. So first I see Charlotte right here. And do you guys see where Winston-Salem is on the map? Okay, almost directly north. So I would say northeast, right? So if I take 0 and line this up, I'm also showing this because don't you guys, I believe you guys use a similar utility in Park where they give you a ruler. Okay, so if you guys look at what I'm doing, I'm starting where 0 is. And do you guys see where Winston-Salem's mark is at? So it's a little more than 1.5. It's actually, each of these is 1/10 of a centimeter, right? So this is 1.5. That would be 1.6. Do you guys see that? So 1.6 centimeters. So if that is the relationship right here, and it's 1.6 centimeters, I need you guys to figure out what is the actual distance from Charlotte to Winston-Salem. Can you quickly calculate that? And that's a really good exercise for you guys that are still fuzzy on multiplying decimals. I see a number of people that haven't even tried this problem. They're talking about something that's completely unrelated. When you have your answer, if you can put your pencil down, please. Laurabelle, were you able to get something? Were you able to get the answer? Olamide, you almost done? How much? When you're done, could you share your answer with the class? Uh-huh. How much?
375 meters.
375.
300 to 3.75.
Caleb, can you help her out?
I've got 120 kilometers.
Right, so here's what we got to do. Shh. Shh. Okay, looks like a few of you got the same thing. So here's what we have. I couldn't use this ratio in this form. So I had to take the reciprocal because I want my centimeters to cancel. Do you guys remember what Terrell was talking about with the last problem? So I have to get my centimeters to cancel. I want to be left with kilometers. So here, if my centimeters are in the denominator and my kilometers in the numerator, those centimeters cancel out, and it gives us back 120 kilometers. So the actual distance from Charlotte to Winston-Salem is 120 kilometers. Okay, so that was the example. Now they want us to find the actual distance. I'm pretty sure we could double check it on MapQuest, Google Maps. Anyway, take a look. Find the actual distance from Charlotte to Raleigh. So here's Charlotte to Raleigh. Let me go ahead and measure this. And when we measure it, I have my 0 on Charlotte, and then here's Raleigh. Raleigh is starred. Why is it starred? Do you guys know? It's the capital. So if you guys look at this, this is 2.5 or 2.5, 6, 7, 8. I'd say that's 2.8 centimeters. 2.8 centimeters for Raleigh. All right? So I need you guys to calculate the actual distance from Charlotte to Raleigh. Oren, do you have the answer? What'd you get? 210. Is that what you guys got? So you have to multiply again by the same ratio. And I'm hearing mixed results. I'm hearing 210. Who did somebody get something different? So Oren is actually correct. It's 210 kilometers. So the actual distance from Charlotte to Raleigh, 210 kilometers. Okay. Any questions about these two examples? Miles? What's that? Because when you multiply 2 and 8/10 times 75, you get 210 back. Okay, so maybe you didn't carry or something. Double check your work though. Carter? Okay, did you guys figure out where the mistake was? Okay. All right, moving right along. Now take a look at this. You can use the GCF to find the scale of a drawing or model. Okay? Finding the scale. Refer to the model boxcar. So here it is. We have a toy boxcar. It's from a train set. If you look, just to give you perspective, we have a quarter right here. The length of the boxcar is given in the picture. Okay, refer to the model boxcar shown. The actual length of a boxcar is 609 inches. What is the scale of the model? So take a look. This is 7 inches. So this is a pretty easy example. I'm going to walk you through it. That's my scale, right? But they want you to simplify it if possible, just like you would a fraction. Do you guys understand? So I'm just going to speed up things a little bit. The greatest common factor of 7 and 609 is 7. So that means it's going to be 1 to whatever 7 is divided into 609. So that's the answer. So when I divide the numerator and the denominator by 7, I get 1 inch for every 87 inches. That's the scale. The scale is 1 inch to 87 inches. Okay? All right. Now, this relates very nicely to your portfolio project. The length of a room in an architectural drawing is 10 inches. Its actual length is 160 inches. What is the scale of the drawing? That's an easy one you guys can do mentally. Logan, go ahead.
Every inch is 16.
Right, so it's 1 to 16 is the scale. That means the GCF that we use was 10. And when you divide that out, we get exactly what you said, which is 1 inch to every 16 inches. Caleb.
I got confused for a sec because I got that you can also use different numbers that equal.
Basically, you're simplifying the fraction, right? And so there's only going to be one greatest common factor for the two numbers. In this case, it was 10, and 1/16, that's as far as you can go with it. Okay? All right. Now, if you were to make a model of something, you wanted to make it look similar to the actual object, in this case, a scale model of a sailboat. The boat is 51 feet long and 48 feet tall. You plan to make the model 17 inches long. Write an equation and find x, the height of the model. Okay, well, this goes right back to what we did for our warm-up. So if you guys can set up a proportion and solve so you know how tall to build your model sailboat. Come on, get started, please. Can somebody share with class the proportion that they used to set up? Timothy, what was your proportion? Do you guys remember from Friday's lesson when we made a ratio? We didn't use measurements from the same shape. We used the corresponding measurement from one shape and the corresponding measure from the other shape, right? So what you just did was you took the height and the length of the actual boat and made a ratio. We don't want to do that. Do you guys remember from last week? So that's a big hint right there. You don't want to take the measurements from the actual to make a ratio. You want to use one of those numbers that relate to the scale model. Does that make sense? Okay? I'm not ever going to make a ratio from the same shape. I'm not going to use two measurements from the same shape to make a ratio. You understand? So that's a big hint. You need to change. So, do you have a question?
So would it be 51 over x equals 17 over 48 or something?
Well, they want us to know the height, right? So what's 51 talking about with the boat? The length. So you wouldn't mix and match. X is talking about what? The height. So I need to make a ratio with the actual height and what we're trying to figure out the height is of the model. Do you guys understand? So there's two possible ways I can make that ratio. It could be, what are the two ratios I can make? They're reciprocals of each other. Fatima?
We could do 17 inches to 51 feet.
Right? Or
Or 15 feet to
51 to 17 or 17 to 51. I just like to put the smaller in the numerator, and then I have to be consistent. Okay? So does everybody understand how we set up that proportion? Okay. So here we talked about the length of the model, and here we talked about the length of the actual boat, and these two things made up my ratio. All right? And I had to be consistent. Since I put 17, the length of the model, in the numerator, I'm trying to find the height of the model, so I had to put that in the numerator of the other ratio. That makes the proportion. Do you guys understand? Okay. And then the height of the model, we don't know. We're finding that. I'm making that ratio with 48, which is the height of the actual boat. Okay. And just to kind of speed us through this, cross product property. And when we multiply that out, here's what we have. 816 equals 51x. And then to isolate x, we need to divide both sides by 51. And here's my answer. The height of the model is 16 inches. Question, yes? Do you have a factor that goes from 48 to 51?
No, I did 17.
Uh-huh.
7 goes into 21. That's the last digit of 51, and then that's 3, and then 48 divided by 3 is 16.
Oh, you said 17 goes into 51 how many times? 3. So what times 3 gives me 48? 16. Okay. That works. That actually is very similar to the method somebody used in the warm-up. Who had that? Who had the same method? Was it Timothy? He had a very similar method to Logan's method. Okay. Now, we just calculate the height. Now, for you guys, we need to figure out how wide is the boat. I don't know how wide this boat is. Okay, how wide is the model boat going to be? So you can choose what your variable is going to be, right? For the width. Or you can use x again just for this other problem. Whatever you want. Set up a new proportion. Sign out. Who's got the answer? Who's got this proportion? Somebody I haven't heard from yet would be nice. Jonathan, take a guess. What would your proportion be? Who can explain to Jonathan the steps? Alexis.
First, you're gonna have to make a position out of it. So
Okay.
you take the corresponding section out of the boat because I'm guessing are we using like the same measurements from the question?
Right, yeah, we are.
So, what I did was I used the proportion for length. Which
Okay.
was, 17 over 50.
So you reuse this ratio, very good, and then what?
And then I equal to sign, and then it was let's see. Okay, so we H or no, well, W or
Okay, whatever variable you use is fine.
and then that over 15.
Very good. So I just reused X. I could have used H. So do you guys see how we set that up? Jonathan, this was the length of the model, right? And this was the length of the actual boat, right? And then we're trying to figure out the width, and they gave us the width of the actual boat. Do you understand? Okay, so once we have that, cross product. What'd you get, Alexis?
I'm still working that out.
Okay, I'm going to just speed things up a little bit. So here we go. Cross product. Boom, boom, multiplied these two. You might have another method that you could do it mentally. Okay, so when I take the cross product, this is 17 times 15 is 255, and then 51 times x is 51x. And then again, I have to isolate my variable, divide both sides by 51, and the width is x equals 5 meters. Okay, Saki, question in the back? There's a couple other ways, but the cross product method is kind of like the cookbook method of doing it. Yeah. What's that? Because we had the length of the boat up here was 51 feet long, and then the length of the model was 17 feet long, so we use that to make our ratio. Do you understand? Okay, and so in the first problem, we didn't know the height of the boat, the model boat, but we knew the height of the actual boat. That's why we made the ratio here. The height, and then here's the height of the actual boat. So the height of the sailboat, the toy sailboat, the model, and then the height of the real sailboat, 48. And then down here, we reuse the same ratio for the length, but instead of height, this time we have the width over the width of the actual boat, 15. Okay, so then we use cross product to solve the width. Okay, any questions? So this is very similar to what we did on Friday with similar figures. Okay, yep.
You have still gotten the same answer if you use the actual height of the boat to the models?
Okay, so Thomas has an excellent question. Because we knew this was 16, I could have used 16/48 instead of this. Do you guys understand? So 16/48 and then equals x over 15. It would still give us the same answer, yes. Okay, and if you remember from Friday, when we had similar triangles, I said, hey, there's a couple other ways we can do this. Do you remember? And the rectangles, right? Same thing here. All right, so here we are, end of the lesson. Vocabulary, a scale is a blank that compares a length in a drawing to the corresponding length in the actual object. So I gave you one of them. What's the first one? Who's got the first one? Go to Fatima. It's a ratio. A scale is a ratio that compares a length in a drawing to the corresponding length in the actual object. Okay, reasoning. Let me get a volunteer for this one. The scale of a drawing is 5 centimeters to 1 millimeter. Is the scale drawing larger or smaller than the actual figure? Explain. I hear some people kind of talking to themselves. Who wants to share with the class the answer? Somebody I haven't heard from. Logan, take a guess. You think it's larger? Yep, that's correct. And can you explain how you came up with that?
Well, it was because on the other scale models, the smaller number is first or 1 is first, so I just knew to switch that.
Okay, so yes, larger. Since the scale is a ratio of drawing to actual, then 5 centimeters to 1 millimeter, the drawing is larger than the actual figure. Okay, can you guys come up with an example where your drawing would be larger than the actual thing? Can somebody come with an example where your drawing is larger than the actual? Caleb,
So,
do you have an example? Just quickly give me an example.
okay, so 2 millimeters over 7.
No. Give me like something, an actual example.
If,
Joshua, go ahead. Drawing of a pencil. Okay, so you can have a drawing of a pencil, but the pencil is actually maybe half the size of your drawing. What's another example? You guys have probably done this in some situation in this place. Miles. A balloon? Oh my gosh. Logan, what were you going to say? A bug? That's what I was thinking of. Did you guys make cell models? Okay. I need you guys to stop talking and listen because we're not done yet. You guys made models of cells, right? The cell is not that actual size. It's a representation of something much smaller. Okay, so bring it back up front. Error analysis. A student wants to write the scale of a statue of President Kennedy, who was 6 feet tall. The student is 8 feet tall. Wait. The student... Here, shh. Here it is. The student's drawing. There's a typo. Shh. I need you guys to stop talking. A student wants to write the scale of a statue of President Kennedy, who was 6 feet tall. The student's drawing is 8 feet tall. The student writes the scale as 6 feet to 8 feet. Is the student correct? Explain. Abu, go ahead.
No, he's not correct.
Why not?
Because it says you need to put you can't put the same type of unit to measure length.
If you think about the question that Logan answered, take a look. Here's the answer. No, the scale should be written as a model, actual, or 8 feet to 6 feet. Okay? The model to the actual. The drawing to the actual. Okay? Are we good? All right. Take a look at this. Last problem. The scale of a map, they're not giving you a picture this time, is 1 inch to 5 miles. Find each distance. A road is 3 inches long on the map. So we need to figure out how long is this road. You guys go ahead. Ladies and gentlemen, I need you to try. There's way too much socializing going on. I see a couple people without even their notebooks out. It's not time to pack up. So I said that and you're still talking. Saki, what's your guess? You think it's 15 miles? Well, let's take a look. Here's our scale. It's our drawing and our actual. 3 inches. And we need to use our scale so that we can eliminate inches. So 15 miles is the actual length of the road. Very good. All right. So I don't know if you can see this at the bottom. There's a lake, and it's 35 miles long. How long would it be on the map? So they're telling you the actual now. They want you to find the length it would be on the map. Jonathan, what's your guess? You think it's 7 inches? How'd you come up with that? So Jonathan's correct. Here's the setup. 35 miles. And then we use the ratio in this form, inches per 5 miles. So if you look, when you multiply across, my miles cancel. And so 35 divided by 5, that ends up being 7 inches over 1. 7 inches is the length of the lake on the map. Any questions?